In this video, we're going to bring in some data, some XY scatter data, and then we are going to make a plot, make a quick plot just using plot, and then play around a little bit, and then use ggplot to make sort of a nicer looking plot and have a linear fit and display the equation for the linear fit and so on. Okay, let's get started. So the data chosen for this is from basketball, this basketballreference.com, and it is the average number of 3 points in a game. And so, and then I went to that site and grabbed, that has a lot of data, not just the 3-point data. And then I sort of simplified my life and just grabbed, throw it over to Excel and then save to CSV. And I just saved the 3-point stat part. So it's up on my website right now. So I'm reading that in and so I have 44. This started in 79. So there are 44 years, and there are two variables, the year and the average number of 3 points in a game. And let's just make a quick plot of the 3 pointers, the Y, tilde, the X for the years. Okay, and here's that quick plot. And one thing we note is something weird is happening in the 90s. And went over to Wikipedia and found out that the 3-point rule was different those for 94, 95, 96, those three anomalous points you're seeing there. So I want to get rid of those for my data. I don't want them throwing off my statistics. And so I'm using R's subset function. So I am taking TP for 3-point. I'm taking TP, and I'm taking a subset of it under the condition where the year, so this is what I'm keeping. I'm keeping if the year is less than 90, 94, or if the year is greater than 96, and I'm keeping the data. So this should come down from 44 to 41. And that's what I'm doing. And then there's two Boolean ORs in R. And one is a vertical bar and one is two vertical bars. And they differ in the way that they deal with vectors. And so I wanted here the single vertical bar which had the right vector properties for me for what I'm doing here. So I'm going to run this. So I should be taking out 3 years. Now I'm down to 41, and then I reassigned it. So I could have just made this a different data frame, but I made it the same data frame. So I sort of overwrote it and got rid of, so those 3 years have gone bye-bye. All right. And now here is my plot, which will look the same, except those 3 points will disappear. Okay. Now, when you work with years, a lot of times it can sort of result, if you're doing like a fit, it can end up with some funny years because your years are starting, in 1979. So it doesn't have to be done, but often people will want, when they're dealing with years, is to sort of start in some convenient year. So I'm going to start, this rule started, I believe, in 79. And so that's when I'm going to start my data. And so I'm introducing a new column, rule year, and that's going to be the year minus the minimum year. Or I could have just typed in 1979. And so now when I run that, I should have 3 observables, or three variables, 41 observations of 3 variables. Okay, so now I have this new column, this new rule year. All right, and now I'm going to plot that, and that's just going to change this year axis, because now I'm choosing, instead of for my X, I'm choosing rule year rather than year. And so there it is. Okay. Now I'm going to fit this data to a straight line. We can argue I'm not going to, should it be quadratic or something, but straight line will be sort of good enough for this purpose. So I'm using LM, linear model. The 3 points are my Y, and my X is rule year now. And then I'm going to do the summary. So I'm going to see down in the console the results. And so we see that there's an intercept and a slope. And the intercept is minus 0.58, and the slope is about 0.27. And the p-value for the intercept is about 0.03, which is sort of acceptable, but not great. The slope is quite small. You want p-values to be small. So the slope, it's not telling you that it is indeed linear versus quadratic, but what it's telling you is that it's better to have a slope than to not have a slope. It's always compared to the null result. So some slope is better than no slope. Obviously, this data is increasing in time. And the intercept is it's acceptable. It's, a lot of people will use 0.05, it's 0.3, so it's under, okay. Now I'm going to extract the slope and the intercept from the data. So the fit has these coefficients, and I can get the intercept by getting the coefficient with a name, with the key value, TP, $rule year, and I can get the intercept having the key value parentheses intercept. You need the parentheses. It needs to be a capital I. You're matching strings, you're matching keys. They have to match exactly. That's why I often like the summary, because then I will copy and paste from the console up here to make sure I'm exactly matching. So this is me extracting my slope and intercept. I'm going to make a fit version of the equation. So I'm just using paste. I'm putting together y equals the slope times x plus the intercept. And I've rounded here because while when it's reporting the values to you, they look rounded. What's going on behind the scenes will have many more decimals, and this will sort of take up too much space. I want to actually, in the end, put it on my graph. It'll take up too much space if I have all of the decimal places that it actually gives me. So I've rounded my slope and my intercept. And if I were fancier than I am, then I might do some if and say if the intercept was negative, then paste the equation together slightly differently so I didn't have this plus minus, but I didn't. So you can do better than me. Okay. Now I have a basic graph and I have the data the way I want. I have a fit that I want to use, and now I just want to make it look nice. So I'm bringing in now ggplot, so library ggplot2. If you haven't installed previously, you'll have to install. I have it, but I do have to announce that I'm going to use it. And then I am taking the TP data, and on my X are going to be the rule year, and my Y is going to be the 3 points. And I'm doing a geom point, so that is going to be making sort of an XY scatter. So that's the sort of ggplot version of just plot. And so it's made this plot. It gives you grid lines and so on. It's a sort of nicer looking basic plot than, that's the whole idea of ggplot. Okay, and now you often see ggplots with lots of pieces all sort of pieced together, all chained together in one big thing. I tend to break it down. So you see this structure of I saved my result of ggplot got saved into my underscore plot, and then I display my underscore plot, and then I keep adding to it. So it'll be my underscore plot equals my underscore plot plus some new piece, and then my underscore plot to display it. So next, what I'm adding, and the chaining thing works, and it may be more efficient, but I like this to sort of slow it down and understand what each piece is doing individually. So here I'm adding some overall labels, a title, an x-axis label, a y-axis label. There are my improved labels and title. Okay, next I'm adding a theme. I'm going to change some colors. So I'm going to, this is my, what is now gray is going to turn to a light sky blue. This what is white around the edges is going to become a dark red. My plot title up here is going to be in white because I'm putting it in this dark red region, so I want a good contrast. And it's going to be size 14 and bold. My X title, that's going to be the numbers. I'm not specifying X or Y, so it's going to be both. So the numbers going up and the numbers going across are going to be white and bold and 10-point font. And the title, which are now for me these words, going to be 12 and white and bold. So let me run that much. So there's my dark red, my light sky blue, and all these white things and different, 10-point, 12-point, 14-point fonts. Okay. Next, I've made my, above I had made my fit. I made my model, my linear model. I displayed the fit equation. I haven't displayed it, but I've made one to display. And the first thing I'm going to do is add the line. So geom underscore AB line, I'm making a line. The intercept is going to be the intercept I've got above, which I called my intercept. The slope is my underscore slope. I'm going to make it dark red. It says I'm making it dashed and 1.5. I'd forgotten I had done that. And there it is, a dashed red line. Okay, so control the thickness. You can have dashed or solid or dot dashed or other funny things probably. The color, the intercept, and the slope. Okay. So now I want to display my equation, and I'm going to use annotate for that. And so I'm at, what I'm adding is text. Where am I going to add it? I'm going to add it at an X of 16. So that's, and this is going to be the middle, I believe. So that horizontally, I'm going to be at 16. Vertically, I'm going to be at 10.5. So I'm going to be in this vicinity here. And then what I'm going to add is the fit equation, and I'm controlling its size, making it a size 6. And there's my displayed equation. And then I am done. Everything else is comments. Here's where somebody explaining the difference between the vertical bar and the double vertical bar for the ors. Here's somebody who explains all these various parts that gives you the name of all these things in ggplot. Here's just a list of all the colors available in case you want color names, and they also display the colors, so it's nice to sort of see the color as you're trying to pick it out. And then here is a reference to sort of adding straight lines. You can add any line that you want, horizontal lines, vertical lines, fit lines. And so that was a reference to that. Okay, that's what I wanted to show you in this one. Thanks for your attention.